Imagine something older than human civilization, older than the pyramids, older than language itself, suddenly blazing across our skies. A glowing green traveler from the deep freeze of space, appearing once every 740,000 years, is putting on a rare and magnificent show. This isn't a sci-fi trailer, it's happening now. Welcome to the celestial event of a lifetime, the arrival of Comet 2025 F2, better known as Comet Swan. And yes, you still have time to see it with your own eyes, if you know where and when to look. So grab your curiosity, because this story gets stranger, brighter, and more explosive the closer we get to the Sun. Unlike many comets discovered by massive research facilities, this one was found by two backyard astronomers with sharp eyes and sharper instincts. On March 22, 2025, Ukrainian astronomer Vladimir Bazougi and Australian observer Michael Matiazo noticed a faint blip in data from a solar instrument aboard the SOHO spacecraft. The instrument? Not even meant to find comets. It's designed to track the solar wind, not icy interstellar visitors. But the comet's faint ultraviolet glow revealed itself anyway, proving that the universe likes to keep us guessing. And here's where it gets interesting. This wasn't Comet Swan's grand debut. When astronomers combed through past images, they found it had been creeping toward the inner solar system since September 2024, hidden in plain sight. Back then, its brightness was around magnitude 22, nearly invisible to all but the most powerful telescopes. But now, it's front and center. So, why the hype? First, the glow. That eerie green color isn't just pretty, it's science in action. As ultraviolet sunlight hits the gases being released from the comet's core, especially diatomic carbon, C, and cyanogen, Cn, they light up with a vivid green fluorescence. It's like watching a cosmic chemical reaction play out in real time. Second, the tail. Swan's tail has grown to span over 2 degrees across the sky, that's 4 times the width of the full moon. It's made of gas and dust being blown away by the solar wind, and always points directly away from the sun, creating that classic sweeping motion in photos. As the comet closes in on the sun, its icy nucleus, probably no more than a few kilometers wide, starts to vaporize. This process, called sublimation, releases gas and particles that form both the coma and tail. And this time, it's doing it in dramatic fashion. Oh, and here's the wild part. Comet Swan's orbit is nearly parabolic, with an eccentricity of 0.9997. That means it's practically on a one-way trip. It last passed near Earth roughly 70,000 years ago, when Neanderthals were still around, and after May 2025, it won't return for 740,000 years, if ever. In early April 2025, the comet shocked astronomers again. It erupted. Its brightness suddenly increased, likely due to internal pressure or thermal cracking that exposed fresh subsurface ice. When this ice vaporized, it ejected material with it, causing a rapid rise in visibility. These outbursts are gold mines for scientists. They reveal how heat penetrates a comet's crust and allow researchers to peek into its core without a landing mission. Swan is basically cracking itself open so we can study it from afar. This kind of activity isn't just pretty, it's incredibly rare to witness in real time. And every eruption adds to our understanding of comet physics, heat transfer, and how these icy bodies behave in proximity to solar heat. So how can you see it? If you're in the northern hemisphere, your best viewing window is just before dawn, roughly 70 minutes before sunrise. As of mid-April, Swan is moving through Andromeda and Triangulum, headed toward Taurus, where it will pass close to the Pleiades star cluster around May 1st, its closest approach to the Sun. Expect the brightness to ramp up from magnitude 7 on April 10th, to magnitude 4 or brighter by April 28th, potentially visible to the naked eye from dark sky locations. If you're using binoculars or a small telescope, look for a fuzzy circular glow with a faint tail pointing away from the Sun. In long-exposure photographs, the tail is breathtaking, curving and shifting like a celestial ribbon. In the southern hemisphere, your best chance comes after perihelion, when the comet climbs higher into the evening sky. Beyond the spectacle, this comet carries cosmic secrets. It's made of material unchanged since the birth of the solar system. Studying its gases helps astronomers understand the building blocks of planets, and possibly life. Even more inspiring? Its discovery came not from billion-dollar labs, but from regular people doing what they love. It's a powerful reminder that astronomy isn't just for professionals, it's a cosmic community. And with missions like ESA's Comet Interceptor planning to study similar comets in real time, what we learn from Swan could shape space science for decades. So don't miss your chance. Look up, take a photo, and witness something that won't come back in your lifetime, or your great-great-great-great-great-grandchild's lifetime either. Subscribe for more sky events and cosmic mysteries, and remember, sometimes, the best shows aren't on screens, they're written across the stars.